Good morning. My name is Kyle Houchins. I'm a technical trainer for McNeil and Associates. I also run a consultancy, which is the Outside Digital Art Design. Today we're going to talk about fixing files. We're going to do something a little bit differently. We're going to these videos, by the way, just the getting started videos. We like to do these about once a month to help people get started. Maybe you've just downloaded Rhino, maybe you've had it for a little while and are looking to expand your skill set a little bit. And so we try to put together about an hour, hour and a half little project where we can talk about a specific feature or a specific workflow or something like that, and drill down a little bit and focus on it. Have a little interactive session so that there's some question answer. If you have some questions, you're more than welcome to post them in a chat, and I'll be more than happy to answer that along the way. Today, we're going to do something a little bit different. Instead of actually building something, we're going to talk about what happens when you're sitting at your desk and somebody sends you a file from somewhere else and wants you to either get it ready to print, get it ready to send to a machining process, CNC, SLA, something like that, or possibly solve a data transfer problem. And in this case, this file is as my wife likes to refer to, a hot mess, and has all sorts of problems in it, and would not data transfer, would not print, wouldn't even make a decent rendering, which you'll see in just a second. So we're going to talk about why it won't work, show you some of the tools in Rhino and how to fix it, and then talk about ways that you can take files like this, fix them up, look like a rock star, and be the hero of the day, because you'll be the one to be able to fix this and get it rolling. So this file, first of all, is it's an IGES file. I don't know where it was built, which is often the scenario when you get a file handed to you. You don't know where it came from or who built it or anything about it. So we need to understand a few things about it right off the bat. And one of them is, as an IGES file, you'll notice if we pick this thing, that you'll see that it's not joined. And so the very first thing that we want to do is we want to take this and we want to join it into a Rhino polysurface. So we're going to select everything. We're going to type join, hit enter, and it's going to say right off the bat, if you have automatic checking turned on, it's going to say there's invalid geometry that was added to this model, blah, blah, blah. Flaws are usually minor, make us problems. We understand that because it's a problem to start with, right? So I'm actually going to turn off automatic checking because I don't want this to keep popping up throughout the model. But it's a good little indication to know that we've got a problem here with this file. So I'm going to join this, and then I'm going to select everything and look at the command line. And you'll see down here it says one surface and two polysurfaces were added to the selection. Well, I know that's a problem right off the bat because this file should be one closed polysurface. So if I've got three entities in the scene, that means I know I've got some issues, right? So the next thing we're going to do is we're going to just shade it. And when we shade it, we can see that there's some render mesh issues, right? See this little disaster in here? This is a good indication that that's a place to start focusing your efforts, right? See this down here? Anytime you see a really awful render mesh like this is a good indication that you've got a problem with your file. So we know that, and what do we do about it? Well, let's identify exactly where the problems are. So if we go over here down to the Show Edges tool, I want to show edges, and I'm going to select everything and right-click to accept. It's going to pop up this edge analysis box. And in here, there's all edges, naked edges, and non-manifold edges. In this case, we're interested in naked edges because those are the ones that are causing this non-closed manifold situation, right? So let's dig into that a little bit. We know this one's awful, right? And I'm gonna go to wireframe on this so we can see a little more closely. But we see that there's a pink edge right here, right? See this pink edge? So that's a good indication that we need to fix something here? Well, this is a continuous surface, right? And so it's a little odd that the edge that's not working is here. So if we look at this a little more closely, and I have the isoparams of this file turned off, but let's turn them back on down here. We want to show the isocurves. If we look at the isocurves of this, see how the isocurves are broken? See how it doesn't go to the edge and it doesn't go all the way around? That's also a really good visual indication of what's going on here. So I'm going to make this super simple. Because this is attached to the poly surface, instead of going through the whole hassle of right-clicking over here and extracting the surface and extracting it and then deleting it and all that stuff, I'm going to use sub-object selection, which is Shift-Command-Click, and you can see that it allows me to select a piece of a poly surface, and then I'm just going to delete it. All right, I'm not going to mess around with it. I'm not going to try and fix that surface. I'm just going to get rid of it, and then I'm going to come back over here. I'm going to grab Loft, and I am going to just loft these two pieces back together. Normal, select it, and join. You notice our pink goes away, our isoparams are correct, so this is fixed, right? So let's go and take a look at some of the other ones. Now this one doesn't have a pink edge, right? Let's add the object and see. Well, it does actually have a pink edge. Never mind. This has a pink edge here, so let's do the same thing. Shift-Command-Click, sub-object selection, delete, and then we're going to look at Loft. Again, loft those, and join. That's fixed. So let's look at some of the other stuff that we've got going on here. Let's find some more pink to deal with. I'm going to grab everything again, add objects. When you fix it, it changes the parameters of the object, so you need to re-invoke that show edges. This one has a problem. Shift-Command-Click, get rid of it. Again, loft. These we can rip through pretty quickly. I'm going to select everything, add objects. This one down here is broken as well. You'll very often see holes like this if they come from another surfacing package or some of the solids packages. For some reason, the way that holes like this are calculated in other packages sometimes can be problematic. And so anytime you have a hole like this, you want to kind of take a peek at it and query it pretty closely to make sure that what you're dealing with is clean. And in this case, it looks like we've got most of our holes fixed here. So let's add this back in. And see what else we've got going on in here. So it looks like the majority of our problems are living up in here. Now we can see right away, see this little mess right here? We definitely want to deal with that. And we definitely want to deal with this surface in general. So let's isolate that. And I'm going to type invert, which is going to select everything else, and then hide. And that's going to hide everything except what I picked. So that was invert, enter, hide, enter. And then I'm going to explode this surface so that I can break it up into its individual pieces. And this thing looks like, we look down here, we know it's a single surface. So my first line of defense for fixing stuff is going to be to untrim. So I'm going to actually untrim this. And you can see that right off the bat, that trim edge disappeared. So let's see if these two surfaces will join back together now. And they don't, which means there's probably a problem with this edge. Now, the model itself, this edge, is duplicated from another part of the model. But just for safety's sake, I'm going to come over here and I'm going to duplicate this edge. And that way I've got a barrier to, I've got a border to build to when I bring everything back. So let's show everything again. And then let's take a look at, this is our border edge, and this is our cap. And the cap looks like it's not, looks like it's not good. So I got to plug it in. Hang on just a second. Sorry about that. There we go. So I'm going to get rid of this cap because I have this border edge here and I can build from here to here and know that that's going to be good. So I'm going to do that. And I'm going to loft, first of all, from here to here. Let's see how that looks. I'm not in love with that as a surface, so let's cancel that. Let's build this surface first. So let's loft from here. I want to get clean surfaces. So, and it looks like this object, let's extract this one. I don't want to copy it. That little green box, or that little green arrow that popped up indicated that it was copying. So let's isolate this. Actually, let's take a little closer look at what's going on here. So it looks like there's a little chunk of a surface here, which obviously we don't want. So I'm going to delete that. And then over here, you can see this little fattening here? That's another little section I don't want. So I'm going to get rid of that. So let's invert. And then hide. And then let's take a look at this particular surface. Now, this one has a couple of edges, right? If I shift command click on the edge, you can see that this edge is broken up into several pieces. I don't necessarily want that. I want that to be a continuous edge. So I'm going to come down here under the edge tools, and I am going to merge the edge. Now, there's a couple of ways I can do this. I can merge edge, and then I can merge all edges. I'm going to let's start with merge edge, and I'm going to use the all option here. And you can see that those edges now, if I shift command click on this edge, it's now a continuous edge, so I've repaired that. This is not something that a lot of new users know. You can also do things like this, which is to split edge, right? And I can actually split this edge, and then I can shift command click on this, I can click command drag, and I can actually model off just a piece of an edge if I split the edge, okay? But in this case, I don't want to do that. I actually want to merge the edge. I want everything to be continuous, so I want to merge that edge together. So this is a very useful little tool that not a lot of people who are getting started know about. So I want to make sure that we understand how to use that and what it's for. So anytime you see an edge that's broken up into pieces and you don't want it to be broken up into pieces, merge edge will, to the best of its ability, sometimes it can't be done because of the edge condition, but anytime it can merge the edge together, it will do so. All right, so let's show everything again. And let's do a little bit of joining here and see where we are. So if we join that up, you can see that this edge joined now, which is good. This edge is still open, so we need to build something to fix that. So let's start by lofting this one. And that's not going to be a good choice for that. So let's do something different. Let's do like a 2-rail sweep. Or actually, let's try and cap it. Let's try and do a planar surface and see if we can get a planar surface out of it. If we can't, we'll do something different. Okay, so it looks like a planar surface is not going to work either. So let's do a let's do a 2-rail sweep. So I'm going to draw a curve from here to here, and then let's just do a 2-rail sweep. That'll be a simple way to get this done. Do it in here. That's a little better. I like how those isoparams are tracking around there a little better. So let's sweep it. Let's join it. And then let's check the naked edges again. So we've got one more naked edge here that we need to deal with. And we know we didn't like how loft was going to work there. So let's use something else. Let's use an adjustable blend curve. And let's blend from here to here. Polysurface edge, and 2 is going to be position, and 1 is going to be tangent. And I'm going to just pull this tangency down a little bit. like that. That way I know I've got a really nice, actually I don't like that, so let's do it again. I don't like how that was bending. So let's blend from here to here, using the same statistics with 2 being position and 1 being tangent. Hold on, let me just pull that back a little bit. Say okay. Now we can do 2 rail sweep. Using the surface edge and the surface edge. Sweep. And join. And we should be fixed here now, and we are. So all our pink is gone. So let's see where the next one is. If I hit the zoom, although it looks like, in this case, we may have gotten everything fixed now. So let's take a look and just see. So if we add our objects, 1 poly surface, doesn't look like we've got any naked edges. So let's start doing some checking. So if we come through here, and the first thing I want to do is, let's see, in the diagnostics, the cell open poly surface is hiding in here somewhere, and I'm missing it. Here we go. Select open poly surface. If I run select open poly surface and nothing lights up, chances are this is a closed object, right? So let's pick this and run check. Rhino poly surface object is valid. So let's do one more thing. Let's sell srf. If we sell surf, and there's an individual surface somewhere in this file that's like floating, that's not attached to this, it'll light up. In this case, no object selected. So the last thing we're going to do is sell bad. Sell bad will identify if there's anything in this poly surface. The entire poly surface will light up. And if that's the case, then we can use extract bad surface from this poly surface, and it'll pull out just the bad surface so you can identify it. But in this case, it looks like this is now fixed. Okay, it's a closed poly surface. You can see up here in the properties, which is good, because if it was open, right, let's just open it for a second, and we were to pick it. Now it says it doesn't know what it is, right? If I pick this, oh, it says it's an open poly surface. Okay, so I didn't want it to be open, so I'm going to just undo what I did before. Now if I pick it, it's a closed poly surface. All right, so there's some indications in there of what you're dealing with. We know this is a closed poly surface. It's past check, it's past sell bad, it's past sell open poly surface. So this is now something that we could make a mesh, send it to a printer. We could send it to Pro-E. We could send it to SolidWorks. We could send it to Creo, and chances are it would work just fine. Okay. One little note about data transfer: if you know for a fact that your part has to go to Pro-E or SolidWorks, you need to talk to whoever the folks are that you're working with and understand what the tolerances are they're working with. SolidWorks in particular has an insanely high tolerance. It has to be like, it's like 4 decimal places past the 0 that you have to be set to. Before you touch this file to start with, you want to set your tolerances to match the SolidWorks tolerances. The file out has to have the same tolerance of the file going in to the other package. So if Pro-E's tolerances are 0.00002 millimeters, you have to set your tolerances to 0.00002 millimeters or whatever so that they match, right? I might have added an extra row. But the tolerances from Rhino going from here have to be set before you touch this file. You have to model to those tolerances in order to go out to have it be successful. Otherwise, you got to go through all sorts of fixing stuff when you get into Pro-E or into SolidWorks. All right. So let's look at one more example. If we go to, let's do a new one. By the way, I'm using the Windows theme. If we go to preferences, there's a couple of themes you can use here. I'm using the Rhino for Windows theme. There's the Rhino for Mac theme. or you can set up a custom one of your own. I just like the Windows one because I come from the Windows side. I've got 20 years of modeling on the Windows side, so this feels more comfortable to me to have the tabs and stuff on the top. But if your window doesn't match my window, that's why. Okay, you can just change it up here. All right, so let's check. Let's look at one more. So let's go to this one, and this will be another situation. I'm just going to close this one in the background. I don't like having lots of instances open. So this would be another situation where somebody hands you a file and says, "Okay, we need to get this to a printer," and you say, "Okay, well let's right off the bat let's do cell open polysurface," and we notice something lights up. So we know right off the bat that there's a problem with this, and this will not print because it's open, right? This one is a closed polysurface. If we look here, and we can say, okay, well let's just check this. Well, it says it's a valid polysurface, and let's do cell bad, and we can see that nothing on this lights up. So this is a closed polysurface that's valid. So we can pretty much assume that this one is okay. So if I go to my layer stack here, I can make a new layer, and this one I'm going to just call that okay, and we're going to move objects to this layer, and then I'm just going to hide it. That way I know that that's okay, right? Now, this one failed cell open. It also failed cell bad, right? So let's shade it and take a look and see what's going on. Well, if we spin around this, everything looks okay until we get here, and you can see that this surface is transparent, right? That's chances are that's where our problem lies. And so because cell bad lit something up, right? If we do cell bad, that lights up. We can come over, we can also do extract. Should be an extract bad face. Bad. There we go. Extract bad surf is the command. So let's run that. And then let's check this polysurface. And we can see, I'm going to turn off automatic checking because we know there's a problem there. And the extract bad surf actually pulls out the bad surface. Well, that's great because then I can invert, hide, and I can drill down very quickly on where the problem in this file is. See how that worked? Cell bad, lit the whole thing up. Extract bad surface, pulled out the bad surface. Invert, hide, and we're immediately into where the problem is. So let's take a look at this. Let's show the edges and see what's going on here. We can see that this is a mess, right? It's got actually an internal edge in here, which makes no sense whatsoever. Okay, there's no reason for this to have an internal edge like that. So what's the first thing that we want to do to try and fix that? I'll let you think about it while I take a drink of coffee here. Hang on a second. The first thing we want to do to try and fix this is we're going to untrim. That's always our first line of defense to fix a surface, is we want to go back to the original surface. And when we untrim, we may want to keep the trim objects, right? So let's do that. Let's untrim. And we can see that the trim boundary on this thing is a mess. I'm going to hide this over here for a second. Actually, I'm going to throw this on another screen so it's out of the way. We can see that the trim boundary is a mess, right? And so if I pick the trim boundary, I can say, okay, well, that makes no sense. That makes no sense. This surface, this entire trim here is probably a problem. So I can do a couple of things. I can explode this curve. I can delete that, and I can delete that, and then I can connect this curve and this curve. I think I missed it. This one and that one. Nope, not going to let me do it. So I can either extend this. Let's extend the curve. And that's the boundary I want to go to. And that's how I want that to shoot out there. So let's zoom in closely and see. I'm still missing that. So I'm going to take this and I'm going to trim it. and it's not letting me trim. So that means there might be a problem with this curve, right? So let's back out a little bit and take a look and see, is there a problem with this curve? Now, we can pause here for a second and say, okay, how much time do I want to spend fixing this jank curve? Do I want to spend the time to go in and deal with this? Or do I want to just delete all of this, bring back my model, and then use the boundary edges that this patch is supposed to fill in the first place to trim? And I'm thinking that's probably a better use of my time. So let's do that. So let's trim, but then let's use the CRV switch. If I hit curve and hit enter, now I can pick surface edges as input. Instead of having to pick a surface as an input, I can pick curves or surface edges as an input. And that gives me the ability to then trim based off this. Now, if I undo this for a second, if I were to try and trim this using the surface without the curve switch, it didn't work. Not only didn't it work, but it gave me completely the wrong thing. So I didn't want that. So we were going to trim CRV enter. That switches modes on Rhino and allows you to be able to pick curves or surface edges as trim objects. That allows me to get to the right solution, join enter, and lo and behold, two surfaces are polysurface joined into one closed polysurface. Go over here to the properties, closed polysurface, back to the beginning. Let's go through our checks. Check. Rhino object is valid. Cell open. It passes cell open because nothing lights up. Cell bad. It passes cell bad because nothing lights up. So now we can switch this to the OK layer. And now we know both of these parts, if we were to create meshes of these and send them out to a printer, they would print. Okay? We could data transfer them as long as our tolerances match. And I want to talk about tolerances for just a second. So if we come up here to units, and I'm in the wrong spot. Settings, here we go. In units, okay? Absolute tolerance. This is the number that you need to match with wherever it's going. So if this is going to SolidWorks, this needs to be a smaller number. It needs to be like 0.000285364 or whatever their tolerances is. It's an insanely high number. If SolidWorks people are out there listening, your tolerances are insane. And you are causing problems for everybody else in the industry, so stop it. Anyway, they're not going to listen to me. So because they're not going to listen to me, then we have to then compensate for that by saying, okay, we need to match this number with whatever the packages it's going to. If it's going to Creo, you need to know what the Creo tolerances are. If it's going to Pro-E, you need to know what the Pro-E tolerances are. If it's going to SolidWorks, it's got to be SolidWorks, on and on, okay? If it's just going from Rhino to a printer, you're fine. If it's going from Rhino to a CNC machine, you're fine. All right, but if it's going to a solids package, you need to understand what the tolerance of the inputting package is going to be in order to have this transfer successfully. Otherwise, they'll kick it back and say, this is not a closed model. And you're like, it is. I'm looking at it in Rhino and it's closed. And they're going to say, well, it's not closed here. Well, that's because your tolerances are not high enough. Okay, this is the bane of my existence as a consultant dealing with other engineering folks and things like that. They may be nice people, but their tolerances are insane and they make me crazy. So that's the one thing you have to understand if you're going to data transfer. All right. So from this point, we know that if we were to take these two objects and we were to mesh them, and let's go to the advanced stuff, and let's set a few things here. So the maximum distance edge to surface, we want to match this tolerance. Whatever this tolerance is right here, that's what we want in this box right here, okay? Because that is our file tolerance. So that's as far as a polygon can get away from the surface of this thing. And if I preview this, it's going to be a decent mesh, right? But if we look at this, see how it's kind of messy? So now we want to start messing with the maximum edge length. And at this point, because we're working in millimeters, I'm going to say 5 millimeters is the maximum. So let's preview it. It does a tighter mesh, but that's still not quite enough polygons. So I'm going to take this down and I'm going to say, okay, let's do a millimeter. That's starting to feel a little bit better. See how this mesh is starting to tighten up a little bit, but I would even feel comfortable with a few more polygons. So let's go 1/4 millimeter. Now we're talking. So if I say okay, it's going to think a bit because it's added a bunch of geometry here. And then if I say cell mesh, and then I say invert, hide, now I can see what my mesh is doing. All right, this would be a decent mesh. This is something that you could send to a printer and do just fine. All right, we're going to check this, cell open mesh. Nothing lights up, so we know this is a closed mesh. So we know that we can send this to a printer and be okay. All right, so there's a bunch of select tools. There's cell curve, CRV. There's cell surface, SRF. Cell open surface, cell open curve, cell closed surface. Okay, I guess closed surface would be a polysurface, closed polysurface. All right, so all sorts of different ways that we can check this and verify that it's good. So in about, geez, we did that quick. And in about a half hour, we fixed 2 files, right? We look like a superhero in our office because we fixed the thing that somebody else screwed up, and we're out of here. All right? Any questions on any of that? If not, I think I'll just leave this one short and sweet and let you be on with your day. Hope you enjoyed it. If you have any questions, you can email me, kyle@mcneil.com, or tech@mcneil.com is actually a better way to get a hold of me because that is goes into the general tech pool at McNeil. I want to talk just a second about some learning resources. If I come here and we go to learning resources to help you get going, rhino3d.com learn. Make sure that you're taking advantage of this stuff. Okay, there's all sorts of tutorials in here that you can get to. The other thing that I want to point out is we have a Vimeo page. Everybody's like, what's a Vimeo page? We have a Vimeo page. Oh, I want to get to our, let's see. Rhino 3D, that's what we're looking for. This one. Nope, we have a channel. Sorry. There we go. I think this is, yeah, this is our page here. This is it, Rhino 3D. Sorry. I want to get you to our main page. So here we go, Rhino tutorials. I should know this. I'm going to put this in the chat so you can have it. Vimeo.com/Rhino. This is our video page. There is 541 videos on here that you can dig through. All sorts of stuff. And then also I want to point out our learning resources. If I come back here on the learning page, there is on-demand classes. You can take level 1, level 2 at your own pace. These are paid classes, but they're pretty cheap for what you get. We also do live online classes if you want to sign up here. I don't think we have anything scheduled right this second, but this is where you'd find those. And let's see what's going on in California. Nothing right this minute, but this is where it would get posted. Oh, Gary Dawson is teaching a level 1 class. Gary's awesome. That's a good deal. And then Getting Started Live, this is where you register for these if you want to get information about these for the next month. Okay, so that's all I've got for you. I hope I answered all your questions. If you have any questions, like I said, tech@mcneil.com. You can shoot us a question about any of that. This video will be posted on the Vimeo page, so if you want to catch up with it later, you're more than welcome to check it out there. All right. Hope you enjoyed that. Thanks for joining us. Go make awesome stuff. My name's Kyle Houchins, and this is Getting Started with Rhino for Mac.